Which of the following is not a characteristic of students' t distribution? Now, we've been studying normal distribution for a long time. In this section, we will talk about students' t distribution. And actually, the t distribution looks very similar to the normal distribution. In fact, if you were to look at the t distribution curve by itself, you wouldn't be able to tell whether that's a t distribution or a normal distribution, because just like the normal curve, it's symmetric with respect to the center, and the curve has the same basic bell shape. So in this picture, you are looking at different student t curves, and they keep changing as the sample size keeps changing. So this new, that's actually sample size -1. It's called degrees of freedom. So with nu equals 1, it means the sample size is 2. With nu equals 2, the sample size is 3, because nu is always 1 less than the sample size. So we are seeing here that for a lower sample size, the curve is low and kind of flat. And then as the sample size increases, so for example, when nu is 5, it's this light blue curve. So it's this one. So it's become a bit steeper. And then as sample size becomes very large, that's plus infinity means that it's getting very large, then it takes the shape of this black curve, which is the normal curve. So as the sample size keeps increasing, the t distribution starts becoming more and more like the normal distribution. But as we said, this distinction can only be observed when you're looking at the normal and the t curve on the same graph. If you look at them by themselves, it's hard to tell whether you're looking at normal or t. So let's see, with this introduction, if we can answer the question, which of the following is not a characteristic of students t? The distribution is symmetric. No, this one is a characteristic. The distribution depends on the degrees of freedom. This is also a characteristic. As we saw, degrees of freedom is 1 less than the sample size, and it keeps changing as the sample size keeps changing. For large samples, the t and z distributions are nearly equivalent, right? That's the remark I made, that as the sample size approaches infinity, it becomes exactly like the normal curve. The distribution is a mean of 1. No, it can have any mean, just like the normal distribution. So okay, so this one is C is a characteristic. Yeah, they are equivalent. So C is also, we're looking for the one that is not a characteristic. So that's the one that's not a characteristic. It doesn't have to have a mean of 1. It can have any mean. Determine the t-value in each case. Find the t-value such that the area in the right tail is 0.02 with 10 degrees of freedom. So when we've been doing normal calculator for a long time, when you have to do calculations with the t, then on StatCrunch you will use t calculator. So here we want, let's first see how we get to the t calculator. So StatCrunch, where is StatCrunch? So what you do is you do stats calculator, and instead of normal you do t. And now let's enter the data. They were saying that area in the right tail is 0.02 and 10 degrees of freedom. So area in the right, so change this one to the right, 0.02, and it's already on 10 degrees of freedom. So let's see. Oh no, the area to the right was 0.02. So the area box is always this last one, 0.02. So 2.359. Two point 359. The t-value, so that the area in the right tail is 0.25 with 6 degrees of freedom. So area is now 0.25. And change the degrees of freedom to 6. 0.718. T-value area on the left is 0.15 with 9 degrees of freedom. On the left now, so change it to the less than. What was the area? 0.15 with 9 degrees of freedom. So area is now 0.15. 9 degrees of freedom. Negative 1.099, so negative 1.1 to 3 decimal places. Find the critical t-value that corresponds to 80% confidence. So remember, we had a similar problem in the normal distribution problem, and I told you over there that the level of confidence is the middle or in between area. So the same rule still holds even in t-distribution. Whatever is the level of confidence, that's the middle area, and so you do the in between. So area is 0.8, 29 degrees of freedom. So you go to between 29 degrees of freedom, and area is 0.80. So t values is negative 1.311 and 1.311. And if they ask you for only one, then you take the positive one, 1.311. Sometimes they'll ask you for both of them, then you write both the positive and negative. And now all these hints, they said that use symmetry here. This applies if you are using these tables, and it doesn't make sense to use these tables anymore. StatCrunch is much faster and much easier. So